Good morning, everyone. My name is Fawaz Harbi, and I'm here to present our project on the central limit theorem. This concept is the true foundation of statistical inference. I would also like to thank our supervisor, Professor Qaid, for his guidance on this work. The core concept is that as our sample size becomes large, the sampling distribution of the sample mean will approach a normal distribution. The most powerful part of this theorem is that it holds true regardless of the shape of the original population. Mathematically, if we take a random sample size n from a population with a mean and variance, the sampling distribution has two key properties. The mean of the sample mean is equal to the population mean. The standard error is calculated as the population standard deviation divided by the square root of n. This creates the predictable distribution you see here, covering 99.72% of the data within the three standard deviation. To find probabilities, we must standardize the sample mean into the z-score. We use this formula, which incorporates the standard error. As the sample grows, this standardized variable follows the standard normal distribution, allowing us to use the z-score table shows here. The CLT is powerful for three main reasons. The first one, we have shape independence. It allows for normal calculation even if the population is skewed or bimodal. And secondly, predictability. As n increases, the variance of the sample mean shrinks, making our estimation much more precise. And lastly, inference foundation. It is a mathematical backbone for almost all hypothesis testing and confidence interval in statistics. Let's look at a quality control example. A firm makes a light bulb with a mean lifespan of 800 hours and a standard deviation of 40 hours. If we take a sample of 16 bulbs, we want to find a probability that the sample mean is less than 775 hours. First, we calculate the z-score. 775 minus 800 divided by 40 over the square root of 16, which gives us negative 2.5. Looking this up in our table, we find the probability is 0.0062. This means there is only 0.62% chance the mean lifespan is that low. For the CLT to hold, we need randomness and independence in our sampling. Sample size rule usually n bigger than or equal 30 is required for a skewed population. And lastly, expectation for the original population is already normal. The theorem applies to any sample size. And lastly, we have a knowledge check. So this is like a question. According to the CLT, central limit theorem, what is the general rule of the thumb For the minimum sample size, we need for the sampling distribution the mean to be experimented normal for heavily skewed population. The correct one is n over n is bigger or equal than 30. And thank you for your time and listening.